so jot down the title. We're doing symmetries and odd-even functions. Have you guys heard of odd and even before?
Yes.
Maybe?
Maybe.
You were so confident at first. Hold on, I've got to erase a bunch of stuff for you, so. Don't write anything yet. I know this looks scary like this, but it's not. All right, I can start writing things down. All right, so if something is symmetric to the y-axis, I gave you an example with a point, and then I gave you an example of an actual graph that is symmetric to the y-axis. I'm pretty sure you guys know what this symmetry is. Am I correct? You don't know what symmetry is? Oh, you do know what symmetry is. Okay. So symmetric to the y-axis. Fold it in half along the y-axis and everything would match up. That's what we're talking about. And then the second example there is symmetric to the x-axis. Make my hand. I'll let you write and then I'll tell you more. And then there's a third symmetry coming, so. No, we are not into the z-axis. That is a thing, but not this year. Like if you graph in 3 dimension. It's hard. We don't have time for me to teach you how to graph with the z-axis today. Sorry, guys.
Not today.
Not today. Maybe another day. Definitely not. That's a calculus thing.
Do we do this like class all the way up to? I mean, like after the final, is there more classes, or is the final class?
Okay, so a lot of people have asked me this today, guys. It's funny. It's come up multiple times just today. First, you guys do not have an SOL. Okay. It's not an AP class, so you don't have an AP exam. Okay. All you have is your final. I teach you up until the final. The final exam is like, it's the last day. There's no like take the final exam and then come back for classes. You have that weird plaid day that's like 2 hours long on the very last day of school. But other than that, there's no like, there's no classes.
You can just come to the last day.
Well, I don't care if you come on the plaid day or not. Like that's up to you.
Oh, the day before the class.
Yes. That's when exams are. It's like the 4 days leading up to that, and it's half days. I think that's not how this works, right? Yeah, so if you have all A's or A minuses every quarter, you still have to come, but you don't have to take the exam. You can be exempt. You'll do something else that will not be too painful. Yes, yes, better.
What percent of her final grade is the final exam?
10%. 10% of the overall grade, yes. Okay? Does that clear that up?
Yes.
Okay. Yes, lots of people have asked today. It's just funny. What then?
What's the password? It'd
be cool if I just knew that off the top of my head, but I do not. People who study do fine. People who just show up and take it do terribly on it. It's your choice whether or not you study.
How do
So.
you study? Like, what's the method?
I'll put some review stuff up on Blackboard, but just go back and practice every unit because it is cumulative. It is all multiple choice. I believe it's all non-calculator. So like any of the calculator units, it's just sort of like a setup of the problems, but not actually like finish it. All right, guys. Symmetric to the x-axis. Is that going to be a function? No, this is not a function, guys, right here. So we don't do too much with symmetric to the x-axis other than you occasionally have to identify it. We will do symmetric to the origin. This is sometimes called rotational symmetry too. You guys notice our original point, both the x and y change sign to be rotational symmetry. So I'll have you do something once you guys draw this graph. So definitely draw the little cubed looking graph. Let's get through those so then we can talk later. I gotta make sure we actually finish today. It's 2 trig quizzes to pull out. Alright guys, do you have the little graph drawn? Do you have this drawn? Okay, pick up your paper. Literally hold your notes up. Everyone do it. Okay? Everyone does not have their notes up yet. Look at the graph. Alright, you're going to rotate your paper 180 degrees. That was only 90, Ben. There you go. Alright. So, now look at your graph and compare it to this one.
It's the same thing.
Ah, that's what rotational symmetry is, okay? If you rotate it 180 degrees, it will look exactly the same. Okay? Now you know. All right. We're going to talk about determining if functions are even, odd, or neither, and that actually relates to the type of symmetry a graph has. So I want to add a little bit before you start writing this, okay? So if f of negative x equals f of x, we have an even function, and it's going to be symmetric, I'm abbreviating here, okay, to the y-axis. If f of negative x equals negative f of x, you have an odd function, and it is symmetric to the origin. Can you see that okay? I'll scroll down more for the rest. So guys, this is what we're going to use to prove or determine if functions are even, odd, or neither. So I'll let you write down the rest of what's up here. You get exactly the same. That's the first part. It's an even function. Opposite, you get an odd function. Okay, and I'll show you with examples, but I'll let you write before I tell you more. All right, guys, you have it written down? No? Okay. No, so that's the whole reason we don't really use the symmetric to the x-axis much, because it's not a function, and everything we're dealing with right now is a function. Yeah, so it's a thing, like you can be symmetric to the x-axis, but it's not even or odd, because it's not a function. Right, vertical line test, yep. All right, are we ready now, guys? Okay, Fletcher, are you with me?
Yes.
Okay. What you're going to have to do is plug in f of negative x. You must show all of this work. So everything I'm writing, you need to write, okay? I'm not writing extra stuff. You just have to write what I write. F of negative x equals, and then I'm plugging it in. So parentheses, negative x squared minus 5. That's just doing function notation, replacing the x with a negative x. Okay, then we simplify it. What happens when you square negative x? Yeah, so it's just x squared, right? And then minus 5. So what you are doing then is comparing it to the original. Is it exactly the same, completely opposite, or just different?
Exactly the same.
Exactly the same. So what kind of function is this? Yay. Okay? We're done with number 1. Yes, but it's kind of like proofs. If you don't have work, you're going to lose, like, all but one of the points.
Yeah, I got you.
Okay, guys, did everybody write down f of negative x?
Yes.
Yes, you must have that in your work, otherwise you won't get full credit.
Why do you think that f of negative x?
So that is the definition of even and odd. If f of negative x equals the original, it's even. If f of negative x equals the opposite, it's odd.
We just put negative x in.
Yes, because that's proving it for any x value. Okay. You can't do like, oh, I'll put a 2 and a negative 2 in. Okay, great, that shows it for 2 and negative 2, but that may not be true for all x values. Okay, Ben?
So whenever you use symmetric to x, I have to say like,
Nope. Other than just like identifying it or labeling a point, something like that. But it has nothing to do with even and odd. Okay? All right, jot down number 2 for me. Sorry. Good.
Can't function on one function.
Okay.
I thought it was funny.
Nothing like some good math humor. Yes, Alex. Oh, you missed the last one. Mm-hmm. All right, guys, everybody have it written down. Okay, what do we begin with?
input negative x.
Yeah, input, negative x. So f of negative x equals. And guys, I use parentheses. You should use parentheses, okay? And don't jump to it being simplified. You have to show, okay, I'm plugging it in. And then you simplify it. So 3 times negative x cubed. What is a negative when you cube it?
Negative
So do you guys see how that's just going to be negative 3x cubed? Okay. And then plus x, just x. Yeah, so that's what I mean by opposite. Every single sign has changed. Completely opposite, so that is opposite. Minus and negative.
We saw only portions that it was opposite.
Then it's neither. Because then it's just different. It's not totally opposite, not totally the same, neither. And honestly, like most of the graphs you graph regularly are neither. You know? So, you know, of course, most of the ones we'll do algebraically aren't going to be neither, but a lot of them. Okay. Do you guys want to try number 3 for me?
Yes.
Okay. I don't know why I have so much space for number 3. All right, guys. It's a different, you think?
I think it's opposite.
Right.
No. Right. Yes, I think it's neither.
Think it's neither?
Yeah.
All right, raise your hand if you think it's even. None. Raise your hand if you think it's odd. Okay, couple. Raise your hand if you think it's neither.
Neither.
Raise your hand if you're too scared to vote.
Come on, guys.
All right,
Be
just one.
confident.
Okay, so we're okay with the first step, right? When I simplify, this would be negative 5x cubed. Now, you have to be careful. Order of operations. Do I multiply first, or do I do exponents?
Exponent.
Exponents. So squaring a negative makes it positive, and then times the negative 2, it's still going to be minus 2x squared. Yeah, it's neither. So if you look, do you guys see it? It's not totally opposite, not completely the same. Like, it's just different, right? That's neither. Okay? Good so far, right? All right, I'm going to throw fractions in.
Shoot.
You can do it. Ben, come on. All right, jot this one down, and then we'll talk about some things. That's an X, by the way.
Yeah. Who's this guy with the top?
No, I'll explain. Neither? Yes? Okay, good. Okay. Before we actually start going through our f of negative x, let's think about fractions over to the side here a little bit. Let's say I start with the fraction 2/3. What is the opposite of 2/3? 3/2 is not the opposite of 2/3. That is the reciprocal of 2/3. No? Okay, guys, let's start simpler. Yes. Guys, if I start with a 5, isn't the opposite negative 5? Okay, so 2/3, what's the opposite of 2/3? Okay. Ben! Ah, you just missed it all! Come on! Okay. Ben, so 5. What is the opposite of 5? No. Yes. Opposite just means other sign. It does not mean reciprocal.
Oh, yeah.
Okay, so what is the opposite of 2/3? Yes, okay. Now do you guys agree that that is negative 2/3?
Yes.
Do you also agree that that is negative 2/3?
Yes.
Yeah.
Okay. What about that?
No.
No, because doesn't that just equal?
Yeah, that does.
Okay. So if the numerator changes sign, but the denominator doesn't, or vice versa,
Opposite.
that's opposite, and that's how you get an odd. If they both are opposites, that gives you even. Okay? So every one of these fractions, I'm going to have you at the end write same over opposite, or opposite over same, or opposite over opposite, or just if any of them are different, then the whole thing is just neither. Okay? So let's go through the first one. We're going to do a few of these. Start the exact same way. Negative x cubed plus negative x 3 times negative x squared. Are we fine with the simplifying? We simplified okay?
Yes.
Okay. I don't want to rush you through this, but I don't want to just sit here if you're okay too. Yes. Why does it not have a negative? Okay. What happens when I square a negative?
Oh, you did. Oh, I guess.
Oh, you didn't see this part? Okay. All right, so let's do this in pieces. Numerator, let's switch colors here. Numerator to numerator. Same, opposite, or neither? Opposite, okay. Denominator to denominator.
Same.
Same. Okay. Opposite over same. That's this guy, right? So what does that mean? Odd. That is your answer. Do we see it? Do it in pieces. Take the time to write out sames, opposites, and neithers in a little fraction, okay? Write this on your paper if you need to when we get to the test. Take your time on these. They're not hard, but they're easy to just ignore a sign somewhere and just be off. So, all right, let's try another one. I want you guys to try this one on your own. Same idea here. It'll be like, okay,
Oh.
Sorry. Okay, guys. First, let's see if our plugging in went okay. Did everybody get it simplified to that?
Yes.
Okay, raise your hand if you think it is even. Raise your hand if you think it's odd. We got one vote for odd. Raise your hand if you think it's neither. We have a few non-voters. Okay. All right, so let's look at it. If I compare numerator to numerator, that stays the same. Denominator to denominator. Different. The one didn't change sign. Yes, so that's what we have to look at. That is different, so it is neither. Okay, you guys are doing great with this. We're okay so far? What happens when you square a negative?
Oh, she's right.
It's good. All right, one more. You guys try this one, and then we have one little thing to do after this that's completely different than the even, odd, and neither stuff. So let's try one more fraction. Hi. What's my gosh?
You possibly got me any questions. I ever retake that.
What?
I just asked just more like 3 questions. I feel like she wanted me to leave.
So you thought you'd come in here while they were learning?
Well, you want to talk? Maybe.
I may not know it off the top of my head either.
Okay. So, when I think that FRQ, C. Like, how would I get it? Yeah, no, it's C.
Oh, see. Okay. Okay, so what does it mean if it has a point?
This second derivative has a 0.
Yeah, so you've got the second derivative. You've got to set it equal to 0 and find that's what make that. Is there a K in the top part?
Yeah.
Yeah.
Well, whenever I do it, I end up with. I was doing a practice problem and I couldn't get the 0 right. So.
Okay. Try writing it out and show me where you get stuck. Okay.
Okay.
There's a whiteboard right there if you want to do it on that.
Like,
Black.
also opposite over opposite to you.
All right, guys. How many think it's even? Yeah. How many think it's odd? How many think it's neither? Okay. What? Even? Okay. Let's look. So f of negative x. Negative 5, negative x cubed, 3x. Okay, so that's going to be cubing a negative makes it negative times the negative makes it positive. And then negative, negative, positive. That is negative. Still negative times negative, positive. It's a whole lot of negatives going on there. All right, so when I look, I have opposite for the numerator. And I have opposite for the denominator. So think about it, negative 2 over negative 3. That's exactly what we started with, right? So that is 7. Okay. That's really loud.
And I don't know why it does it, but then like I can erase it right after. Yeah. It's right in the shot.
Like you're cheating. I'm kidding.
That is weird.
All right. So we feel good about even on and even. Okay. We understand the work you have to show. No being lazy. Okay. We have one more thing to do.
Like, it's as well. Well, you just have to that really fancy one for like anything that doesn't reach oxidation. So like, anything on your normal element is element 2. Oh, you're not going to do that.
Ignore all this red stuff. Write down all the purple stuff. Okay. All right, guys. I know you're not good at writing while talking, so jot down f of x, g of x, and then f plus g and f of g of x. All right, guys. Writing. Ready to go.
Yeah. This is an exciting day.
Well, glad to have you back. Wait, that's what
I think it was your tone.
Yeah, you missed a lot. Like we took out 4 years.
That's a language. I know, I like it. All right, Anna, you got these written down? Yeah, I did. Guys, this part is not hard. It's just completely different from any way you've thought about functions before. Again, not hard. If you like stare at your phone while I explain it, then it'll be hard. But if you listen, see, what? Ready? Are we almost ready? See, someone's still writing, so we'll wait. What? We split it. It used to be one really big unit, and we split it into 2 smaller units, and it is so much easier being 2 separate smaller units. So hopefully it helps you guys out. Because this honestly used to be either the lowest or second lowest test of the year for you guys usually. So it shouldn't be this year. All right. So let's do f plus g. So guys, the only way you can add function values is if they have the same x value. Yes. If the x's match up, then you can add the y. So let's look. Maybe. So I have a -1 here. Do I have a -1 in my x's down here?
No.
Okay. I have a 3. Do I have a 3 down here? Yes. Okay.
Yes.
I know I'm going to have a 3. What do you think I'm going to get for the y part of my point?
-3.
Okay. And then the last one, there's a 5. Do I have a 5 in the second one?
No.
No, okay. So f plus g is only the point 3, -3. That is it. Yes. Is it all?
No.
She didn't even realize you were like stood right there.
And then you distracted her while I was explaining this one thing. Okay. Oh, Vince got it. Perfect. Okay. Yes. So these x values match, right? So that's the x value I'm using. And then it says f plus g, so -2 plus -1. That's all. It's simple, but you just have to see it. Okay? All right, Hannah, you good?
Anna, are you good?
Take back my recommendation. Yes. Then it wouldn't be a function, and we wouldn't be doing it. Okay. Okay. Yeah. Do whatever this operation is. If it had said f minus g, you'd subtract the y's. If it said f over g. G stands for this function. F stands for this function. But the operation you're doing is on the y values. Yeah. Okay. All right, guys, you got to pay attention to the last one here. F of g of x. Okay, g of x is on the inside. So I have to start with the g function. So what this means, 2 gives me a 5, right? An input of 2 gives me an output of 5.
Yes.
I need to look and see in the other function, is there an input of 5?
No.
An x value of 5?
Yes.
Yes. And what does that give me as an output? A 6. So any guesses as to what the point is going to be?
6.
2, 6. Okay. All right, so the next one. I start with 3. It gives me -1. Is there a -1 as the input on that? Yes. What does it give me? So what's my point? 3, 2. Okay.
Oh, okay.
All right.
Is there a
4
three?
gives
Yes, there
me
is.
3.
So it's good.
3 gives me
4, -2.
yes. These are weird. Yes, we're gonna practice one more of those just to make sure you got it. But are we okay? 2 gives me 5. 5 gives me 6. So it's like the 5s have overlapped. That leaves me with a 2 and a 6 and a 6 and a 1. Now, guys, if it had been g of f of x, it would have been different. Okay? The g was on the inside, so that's why it started with this function. Okay? All right. Let me just show. I don't think we even get anything. If I did this, okay. So -1 gives me 2. 2 gives me. This would be the point. -1 plus. Yeah. And then you'd go. 3 gives me -2. Nothing. 5 gives me 6. Nothing. So the only thing would be -1. Okay. Does that make sense? All right, let's look at one more of those. Not that. We don't really have too much time for whiteboard, so let's do. Ah. All right. Jot down number. I don't know what number this is supposed to be for you. Make it guess. You're gonna get to the end of the day.
America, America. We are born.
Yes. America. This is the background music.
And G of x equals B of x.
Just outgrowing. All right, guys, how we doing? Do you have all 4 answered or not yet? B, match up your x's, and then it's the y value over the other y value.
Oh, okay.
The f1 over the g1.
So only unless it has like G or X or F of X balance with it.
Yeah, so like so like these two, you think of differently when you do the first two. Guys, let me put the answer for A just to see if you're off to a good start. Let's see. 2, 1, 7, 7. Right. How do we do on A? Yes. Okay.
I did not get the other one though.
How we doing on B?
B is a little bit tricky.
I think. So does that one, you're already trying to find the first, the same X values still?
Yes. So guys, B is exactly like A, but instead of adding our y values, what are we going to do with our y values?
We're gonna subtract, divide. Oh, I thought it was like a trick question.
No, you're going to divide. So if I start with matching x's of 2, I get 1 over 0.
Undefined questions done.
No. Okay. Good enthusiasm there. Yes, that's undefined. That's not actually a value, so that's not going to be part of our answer.
Oh, shoot.
Okay? What do I get when I deal with the matching 7s?
1. Oh, wait, no.
5 over 2.
5 over 2.
And that's the only answer you get. Okay? Because the other one gave you an undefined value, so you don't include it. Okay? Anna, you do not look like you approve.
Yeah, I do.
Oh, okay. You sure? Let's do f of g of x.
D first.
D is like no solutions.
Oh, good. D's no solutions? Guys, D's no solutions.
Second?
So it means start with the f of x. So 2 gives me 1, not a 1, not a 1, not a 1. Okay. Negative 3 gives me 4. Nope. 7 gives me 5. Nope.
So they're not no solution?
No, that was for D. That's starting with the f of x first, because it was on the inside. Letter C, guys, if I start with g of x. So 7 gives me 2, 2 gives me 1, right? So I'd have 7, 1. Negative 5 gives me negative 3. Negative 3 gives me
17. Oh, no.
4. So negative 5, 4. And that is it.
Take touch, take touch.
Okay? All right.
What's homework?
Let's do.
It's related. It's actually related. I don't know what it's related to.
Show all your work in the middle section. Yeah. All of it, okay?
All of it?
Yes, it's not long.
8 divided by
I promise.
4.
Wrong, Fletcher.
It's okay.
What's up?